Well, right now I'm actually in Albuquerque, New Mexico, taping here, and we have with us Dr. Seth Shostack, senior astronomer at the SETI Institute. That's a search for extraterrestrial intelligence. You know, I'm not that far from Roswell, New Mexico, where some people think that a flying saucer fell back in 1947. Well, who knows for sure? But I'm actually here addressing a science conference, because that's what we're going to talk about today. We're going to talk about the science of the search for extraterrestrial intelligence with Dr. Seth Shostack of the SETI Institute, one of the leading organizations that is probing the heavens to find out what's out there. And you may want to go to my website. It's mkaku.org, mkaku.org. I have 4 New York Times bestsellers. The latest one just hit the New York Times bestseller list a few months ago, and it's called The Future of Humanity. We're going back to the moon. In fact, we're going to Mars, maybe Titan, and one day to the stars. The late Stephen Hawking already had plans to build the first starship. It's the size of a postage stamp, blasted by laser beams, but it would reach Alpha Centauri in the Centauri system in about 20 years' time. And who knows, maybe after that, we'll be able to tweak Einstein's theory, create wormholes, and maybe, who knows for sure, journey to the distant stars. So go to my website to find out what I'm up to. It's mkaku.org, or go to my Facebook site. We have 3 million fans on Facebook. And today we are talking about the search for extraterrestrial intelligence with the man himself, Dr. Seth Shostack. Dr. Seth Shostack, you've probably seen him on TV on a number of great programs. He got his bachelor's degree in physics from Princeton University, his PhD from Caltech. His latest book is called Confessions of an Alien Hunter. And he has his own radio program as well. It's bigpicturescience.org. So you may want to check it out if you want to find out what the latest is about the search for extraterrestrial intelligence. So Seth, once again, glad you could be on Science Fantastic.
It's always a pleasure, Michio.
Okay, well, I've asked you this question before, but you were destined to become a professor of physics working on some obscure topic that nobody understands. And here you are, an alien hunter. So what was the turning point? What was the turning point when you suddenly said to yourself, no, I got to be part of this grand search for extraterrestrial intelligence in the universe? What was the turning point?
Well, Michio, you certainly make the first possibility sound pretty attractive, being a physics professor at some unheard of university in some faraway place. That might have been interesting. But in fact, I was doing radio astronomy when I was, at the universities, and studying galaxies, actually, using big radio telescopes. And that is interesting stuff. There's no doubt about it. We've learned a lot about the universe, things like dark matter and so forth, by doing that kind of work. So it was interesting for sure. But on the other hand, it occurred to me even in graduate school, I have to say, that the instruments I was using to try and learn more about galaxies could also be the instruments that might tell us that there's somebody out there. And that was a very romantic notion. So when I later in life got a phone call from the SETI Institute, and they said, hey, did you want a job over here? I was inclined to say yes, and I did.
Okay, well, when you first started searching for alien civilizations in outer space, we had zero planets outside the solar system that could harbor intelligent life. And now, because of Kepler and the hard work of astronomers, 4,000 extrasolar planets have been discovered, and we can now take a rough census of the Milky Way galaxy, our own backyard. So when you look out in the sky at night, on average, what percent of the stars you see in the galaxy have planets, Earth-size, Jupiter-size? What fraction of the stars you see on a typical night would have planets going around them?
Well, that indeed was the big development of the past 20 years, I guess. One of the biggest developments in astronomy, because you're right. When I was a kid and, would occasionally go to the Hayden Planetarium in Manhattan there, they would tell you, well, we don't know if there are planets out there or not. We think there probably are, but it could be that making planets is a very difficult process, and there really aren't too many, and you should be grateful for the 9 we have. I guess it's 8 now. So, that is a big discovery to find planets around other stars. And the people that do that, there's some of them actually even here at the SETI Institute. I used to ask them on a regular basis as they were finding more and more of these things, well, look, if you had a perfect telescope, what fraction of stars indeed do you think would reveal themselves to have planets? And the numbers were 70%, 80%. Well, for an astronomer, 70 or 80% is the same as all. Now, there is one caveat. So, I mean, if you say all, then that means when you look up at the sky, essentially all the stars you're looking at have planets. On the other hand, it's also the case that when you look up at night with your eyes, you tend to see the brightest stars. You're not seeing the average stars out there. They're too dim. Stars like the sun. You don't see those. You see very, very big stars that burn out very quickly. So they may have planets, but they're not going to be planets that ET is likely to be on because they don't live long enough for life to get started and get to the point of developing something intelligent. But in general, 70, 80, 90, 100% of all stars have planets. That means in the Milky Way galaxy we have roughly 1 trillion planets with a T.
That is amazing. Now, years ago, you were quoted as saying that, who knows, maybe in 20, 25 years, we will make contact with an extraterrestrial civilization. So, given the fact that we keep finding more planets every month, has that figure been revised? Do you still think that within roughly 25 or so years, we will make contact with an extraterrestrial civilization?
Well, I have to say, I made that bet, and I promised everybody in the audience, it was just a talk I was giving somewhere, but I promised everyone in the audience I would buy them a cup of coffee if I was wrong, if we didn't find a signal coming from ET within that time. Now, on the one hand, I'm buying a lot of Starbucks stock, but on the third hand, I still stand by that. And it's not so much because we're finding more planets, although that's important. At this point, we already know that planets are common. The basis of that bet that I made with the public is that the equipment, the technology being used for the search is getting better very quickly. It's essentially following what's called Moore's Law and kind of doubling in speed every couple of years. So that means that this search is getting faster and faster, and it was on that basis that I made this bet. So, yeah, I still stand by that. I may have to buy a lot of coffee, got to tell you.
Okay. Well, everyone knows that when you see a science fiction movie, you want to see the money shot. You want to see the alien. So the movie Contact that Carl Sagan helped to inspire, I thought was a little bit disappointing at the end because you never get to see the alien at the end of the science fiction movie. But now you are saying that perhaps when we do meet aliens from outer space, they may not be biological at all. I guess given the rigors of traveling from star to star. So what are your thoughts now? You've changed your opinion a bit. So you're saying that intelligent life, once they land on the White House lawn to announce their existence, they may not look like any of the science fiction movies that we all love to see. Well, what are your thoughts?
Yeah, well, they're exactly that, Michio, because indeed, if you look at...
Oh, Seth, we have to take a short commercial break, but after the break, we'll talk about the money shot. What do the aliens really look like? So, once again, you are listening to Science Fantastic with Professor Michio Kaku. You can always give us a call, and maybe you can get on Science Fantastic. So, once again, our special guest today is Dr. Seth Shostack, Senior Astronomer at the SETI Institute in Mountain. Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Dr. Seth Shostack. He's a senior astronomer at the SETI Institute. That's a search for extraterrestrial intelligence. And just before the break, I asked him about, what do the aliens look like? I mean, that's the money shot. When you go see a science fiction movie, you always wait to see, what do those aliens look like? I saw the movie Contact, inspired by Dr. Carl Sagan's novel, And I was a little bit disappointed at the end because the aliens, well, they could assume any shape they want. And so they look just like us. Was that a cheap way to simply save money on aliens? Or, well, what do scientists really think? So, Seth, you recently changed your mind that perhaps they're not all biological like we're used to seeing in Star Wars and the different Star Trek movies. So what are your thoughts now concerning what these aliens may actually look like?
Well, you're certainly right there. It was a little disappointing in Contact to see the aliens and just, see the guy next door, or as it was, Jodie Foster's father, as he was portrayed in the film, when you really want to see the aliens. Now, it's true that the aliens in the movies tend to all look, well, to begin with, they all kind of look alike, but they also look like us. I mean, they're gray and they don't have any hair and, that kind of thing. But
they have funny noses, right, on Star Trek.
Yeah. Yes, that's right. You just wrinkle their foreheads and suddenly they're aliens. But otherwise, they look like, somebody you might pass on the streets. On the one hand, that may save them money, but today with computer animation, that's not really much of an argument anymore. I think it saves them a backstory in the movie. They don't have to explain what these things are. You instantly know, hey, that's an alien. So, that saves some time in the script. But I think that the point is, if you look at what humans are doing, particularly in this century, and you're the expert on the future of humanity here, we're kind of developing our own successors, right? We're building machines that can not only weld cars together, but machines that can think, that can, write the great American novel. And it's, people at Stanford tell me that we'll have a machine that can write the great American novel by the middle of this century. Well, that's a very short time period between developing science and developing machines that can think better than humans can. And at that point, some of them may leave, go into space because there's a lot more energy and, resources out in the distant parts of the galaxy than here on Earth. So the premise here is that the majority of the intelligence in the universe is not soft and squishy protoplasm, but in fact, deliberately constructed stuff, machines. And so if we pick up a signal coming from space, I think that there's a really good chance that what's behind the microphone is not some little gray guy, but some sort of machine.
Or maybe part biological, part cybernetic. I mean, the rigors of outer space are vast. Radiation, accidents, weightlessness. So why not? Why not genetically modify ourselves and cybernetically modify ourselves? So do you think there may be some kind of combination of the two? But, well, what are your thoughts? You've thought about this.
Yeah, well, a little bit. I'm not a biologist. That's one of my many shortcomings. But yeah, we're going to do that. That's for sure. I'm talking to you from the Silicon Valley here, and there are plenty of people within 2 miles of my desk who will tell you that, look, within 20 years you'll be able to surf the web by just thinking the search terms rather than typing them into Google or something like that. That will have chips in your head or wherever. That'll be helping you to never forget stuff and whatever. That's for sure. But in the end, what you're doing there is you're improving this critter, namely a Homo sapiens, who has room for a 3-pound brain. I mean, maybe what you really want is some machine that's the size of an office building that can do a heck of a lot more than whatever you could put in people's bodies. So while I agree with you, I'm sure that we will become more cybernetic ourselves. I think that the real future lies with, sort of throwing away all the protoplasm and concentrating on the machine.
Okay, and let me tell you my point of view. It's something that I've thought about. And, pick it apart and tell me what's wrong or what's right. I think that in the future, we're going to digitize the human body, digitize the human mind. We're going to be able to have all our credit card transactions, internet transactions, Instagram photographs, everything, even the neurons of our brain digitized. And we'll be able to put it on a laser beam because laser beams can transport vast amounts amounts of information. And you could put your consciousness on a laser beam and shoot it to the moon. In 1 second, your consciousness is on the moon. In 15 minutes, you're on Mars. In an afternoon, you're in the asteroid belt. And so you could zip around the entire solar system at the speed of light. And on the moon, there's a mainframe computer where you can download your consciousness, all the bits and things that are necessary to reconstruct human consciousness, and then put you in an avatar. The avatar, you would then feel and walk on the moon as if you are actually on the moon. And the avatar would probably look like you, except you would be superhuman, super handsome. You'd be able to walk on Mars, go past Jupiter. In an afternoon, you could soar across the entire solar system and come back for dinner at the speed of light. No more flying saucers, no more radiation to worry about, no more accidents involving rockets blowing up. No, you travel throughout the universe at the speed of light, and I call this laser porting. And maybe there's a highway out there that was too primitive to figure out, a highway containing millions of souls that are simply teleporting, laser porting themselves across the galaxy. So what are your thoughts? Maybe the aliens are so advanced they don't even bother with flying saucers at all. They simply download their consciousness on a laser beam and explore the universe at the speed of light. What are your thoughts?
Well, I certainly agree with you that the best way to travel to the stars is to do it at the speed of light and not have to worry about, carrying all those lunches with you'll need otherwise. But the problem with this idea, of course, is that you need that machine at the other end that receives the laser beam and then turns it into that avatar. I mean, if it's going to be something with a body and, muscles and all the usual stuff. So that's a difficult problem. And getting that machine out there, of course, is something that's also difficult. But in principle, you're right. I mean, you just want your information, your DNA, for example, the code of your DNA, that would all fit on a CD, if anybody remembers what a CD is. And you could broadcast that on a laser beam in, probably much less than a minute. And it would travel at the speed of light to anywhere you want to go, just as you say. So it could be that that's the way you get around. You don't send the baryons, you don't send the material, you just send the information. That certainly seems reasonable, except for this problem that you have to have something at the other end. That's a little difficult, and maybe that's the case. But again, it assumes that what you're trying to send are biological organisms. We're trying to send, my brother with everything that's in his brain and, all the information about his body. We're trying to send that into space. But if by that point the real intellects of the cosmos are machines themselves, well, then that's what you're sending. You're sending the contents of those machines. It's sort of like, the hard drive on your computer. Just send that into space and forget about all the information about his liver and, elbow and everything else.
Right. Well, as one person pointed out, one bottleneck in my idea is that the first generation to laserport, they have to go to Mars the old-fashioned way. They have to transport silicon and steel and stuff to build a mainframe computer capable of downloading all that information in a laser beam. And then that mainframe computer controls an avatar, so then you feel everything the mechanical avatar feels. But to go to the stars, well, the first generation to go there has to go the old-fashioned way. You can laser port yourself at the speed of light once the mainframe computer is established. But before it's established, you got to go the old-fashioned way. Okay, well, let me ask you another question. Some people say that radio is so 20th century and that aliens of the future may use more advanced ways, maybe lasers, neutrinos, or pi mesons or whatever. But what are your thoughts? What are your thoughts about maybe we're not using the communication system that the aliens would use? What are your thoughts?
Well, indeed, I think I get emails every day or phone calls from people who say, you guys are looking for radio signals from the aliens? Radio is so old school. Well, I mean, we've had radio for a century. To call it old school, I guess that's right. But on the other hand, the wheel is pretty old.
Okay, Seth, we have to take yet another short commercial break. But also, I'll ask you another question. Is it dangerous? Is it dangerous to advertise our existence before we know what the aliens want? So once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 612-564-8135. Leave your name, call letters to the radio station and the city you're calling from, and maybe you can get on almost 100 radio stations that carry Science Fantastic. Welcome back to Science Fantastic with Professor Michio Kaku. Actually, I'm in Albuquerque, New Mexico right now, not that far from Roswell, New Mexico, where some UFO buffs claim a flying saucer crash landed back in 1947. Well, I'm not here to talk about flying saucers. I'm here to talk about science to other scientists and engineers. But we have on the line with us Dr. Seth Shostack, the Dean of the Search for Extraterrestrial Intelligence. He's a senior astronomer at the SETI Institute in Mountain View. That's a search for extraterrestrial intelligence. He got his bachelor's in physics from Princeton, PhD in physics from Caltech, and now spends his day, A, trying to raise money for the SETI Institute, but B, looking at outer space. Now, we talked about the fact that radio is what we listen to eavesdrop on conversations between alien civilizations, but some people say, I mean, that's so 20th century. I mean, come on. The aliens are way ahead of us, but, well, what else are we going to do? So what are your thoughts about maybe using another way to detect alien civilizations in space?
Well, it's true. As I mentioned before the break, I get emails every week, sometimes every day, from people who think radio is kind of old school. But on the other hand, what you have to do is look at the physics of the situation. How can you send bits of information from one world to another? And radio is obviously one way you could do that. Lasers, which are basically the same as radio, because light and radio waves are the same thing. It's just at different frequencies, if you will. So you could send lasers, and indeed we have some experiments where we look for flashing lasers in the sky. But people suggest things like, as you say, neutrinos, gravitational waves are a real favorite, and other schemes like subspace communication, which is what they use on Star Trek. The trouble is, if I go to the local bookstore, I can't find a textbook on subspace communication. So it's really hard to build the equipment. So
doesn't exist, right?
Yes, it doesn't exist. So as far as we know, it doesn't really help to say try subspace communication. We can't try it. We don't know anything about it. But things like neutrinos and gravitational waves, we do know something about. And maybe neutrinos, but the problem with a neutrino, for those who care, is that, each neutrino carries a lot of energy. So it's very expensive to make a whole lot of neutrinos, and it's also kind of difficult to detect them. I mean, there's an experiment down in Antarctica, and, I think it's the University of Wisconsin built it, and it's designed to detect neutrinos, but it's a half a mile on a side. This is a big thing. And it doesn't detect very many of the neutrinos that get into it. So neutrinos are hard, maybe not impossible that you can communicate that way. Think of gravitational waves. They're great. You don't have to point your antenna at anything. The gravitational waves will come from all directions. But to make a gravitational wave that's strong enough for us to easily detect it, you need to do things like smash a couple of black holes together or something like that. That's not a very easy transmitter to build either.
Very difficult.
That's kind of hard. So, maybe radio is old school, but honestly, no matter how advanced the aliens may be, I can hardly believe that they wouldn't use things like light and radio waves for some purpose or other. And so I don't think that it's too chauvinistic to keep looking for these things.
Okay, well, our colleague, Dr. Stephen Hawking, who recently passed away, gave us a warning. And that warning is that watch out. We have to study these aliens first. We don't want to advertise our existence because we don't know what their intentions are. Look at what happened to the Aztecs when they met Cortez. They made a huge mistake, one of the biggest mistakes in ancient history. They assumed that Cortez was a god. Big mistake, when actually he was a bloodthirsty plunderer searching for gold. So, well, what are your thoughts about those people who think it's a good idea to advertise our existence to the aliens? What are your thoughts?
Well,
we have to take yet another short commercial break, but after the break, we'll try to answer that question. Do we want to advertise our existence when we don't know what's out there? You are listening to Science Fantastic.
Hi, I'm Dan Pilla. I started fighting the IRS over 40 years ago when they tried to seize my mother's house. I sued the IRS and won. I beat the IRS then, and I've been beating them ever since. I wrote the book on tax debt settlement, and I've helped thousands of people deal with tax problems they thought might never be solved. I can help you too. If you owe taxes you can't pay, don't wait another day. There's no such thing as a hopeless tax case. Call 800-34-NO-TAX or go to my website, danpilla.com. That's danpilla.com, danpilla.com.
Pain in my neck, back, and shoulders has really gotten worse.
Relief for body pain is here with Sunny Bay heating pads.
Well, the last thing I want is to take another pill, so what's so good about Sunny Bay heating pads?
Sunny Bay heating pads, made by Biomed DB Design right here in the USA, come in all sizes. Our extra large microwavable heating pad for back pain is designed to be large enough to cover your entire back. It's also perfect to wrap around your legs, knees, or shoulder and neck.
But I need to know they're good quality.
Of course, Sunny Bay heating pads and pillows are often an Amazon choice, and it's easy and most affordable when you purchase your Sunny Bay heating pads right from our website, sunshinepillows.com, or call us 253-678-1361.
Hey, a Sunny Bay heating pad
Would make a great gift, right?
Yes, and they start at just $19.99 and free shipping is available. So call 253-678-1361 or shop for your Sunny Bay heating pad at sunshinepillows.com.
Water is the single most important thing your body needs, so you want to be sure it's the purest for you and your family. For over 14 years, thousands have depended on Berkey Clean Water. The Berkey guy has you covered at home, work, and on the go. With water filtration systems of every size for every budget. Now GCN listeners receive 10% off ceramic filter systems using code GCN at goberkey.com or call 877-886-3653. Goberkey.com.
Trading involves financial risk and is not suitable for all investors.
Marijuana has unleashed a green gold rush across our nation. It's creating $10.8 billion in new wealth a year. And every day, it's transforming more and more Americans into millionaires. Former Speaker of the House John Boehner reveals how you could become one of them. Join him online for the American Cannabis Summit. Attendance is 100% free, but space is limited. Join online at www.acs2018.com. John Boehner and an esteemed panel will reveal which cannabis stocks are primed to deliver life-changing windfalls. Plus, they will show you how to become a cannabis angel investor, backing the hottest startups before they potentially become worth billions of dollars.
To join the American Cannabis Summit, visit acs2018.com or text JOIN to 76280. Don't miss this once-in-a-lifetime opportunity. Text JOIN to 76280. Text JOIN to 76280 now.
Brought to you by Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, if you want to get on the air and ask that question that you've always wanted to ask, give us a call at 612-564-8135. Check out my website is mkaku.org, mkaku.org. I've written 4 New York Times bestsellers. The latest one is called The Future of Humanity, about the future of humanity in outer space. We are going to outer space. You know the movie The Martian, starring Matt Damon? That movie cost $100 million to make. But the Indian government sent a probe past Mars for $70 million. So it costs more now to make a movie about going to Mars than actually going to Mars. That's how cheap space travel has become. So, Seth, where we last left off, we were talking about the fact that some people want to advertise our existence to the aliens in our space, give our coordinates, tell them about who we are. Other people think that's a horrible idea because we don't know what their intentions are. So, what are your thoughts about whether or not we should advertise our existence to the aliens?
Yeah, well, it's very controversial. I mean to say, this is an emotional topic. Right? People think, oh, my God, you're shouting in the jungle, don't have anybody broadcast because who knows what the consequences might be. Well, to begin with, the SETI experiments, which is to say the search for extraterrestrial intelligence, such as our own experiment, using big antennas to try and eavesdrop on signals. I mean, we don't broadcast anything. In fact, we don't even have any transmitters, so we can't broadcast. But there are people who indeed want to deliberately broadcast, maybe wake up the aliens. Hey, we're the Earthlings, and we'd love to meet you and hear what your favorite music is or something, whatever, and just send that into space. And of course, that would tell somebody maybe that we're here. And who knows? They launch their interstellar battle wagons toward Earth and incinerate Los Angeles or something. They always seem to go for Los Angeles. Okay, well. It's hard to say that, well, they would never do that. Advanced aliens are just going to be too refined, too sophisticated. They're all going to be peaceful. I mean, you can say that, but you have no evidence that that's really true. So maybe it's better not to take any chances. Well, here's my thought. It's too late, right? Because we have been broadcasting into space since the Second World War, mostly. Of course, there's television and FM radio. That all goes into space pretty easily. But the big signals coming from the Earth are radar because they're very directed. So they're very intense. And a lot of the sky is covered with radar signals every day. So I think that what you could say is this. Any society out there, no matter whether they're friendly or otherwise, any society that could possibly threaten us by sending something our way, right, they are more advanced than we are. And they don't have to be very much more advanced to have systems, receiving systems, that can pick up all this leakage radiation, all these radar sets, or maybe even our television. And they could pick that up anyhow. And so it's too late. I mean, you can worry about this if you want, but we've been broadcasting into space for 70 years. So I do not get exercised when other people want to broadcast deliberate messages. And say, sure, fine, say whatever you want. We've already been telling them we're here.
Okay, so let me ask you then the big question that you've always been asked, and that is, well, why don't they advertise their existence to us? Are they just shy or something? Or are we simply not interesting? I mean, why don't they land on the White House lawn, have a press conference, and usher in an age of Aquarius, giving us the benefit of their advanced technology? We'll cure cancer, we'll live forever, we'll explore the universe, compliments of alien technology. So what are your thoughts about, well, how come they don't visit us? Or maybe they have.
Well, one-third of the public thinks they are visiting. The one-third of the public thinks that some of the lights that people see in the sky are actually alien craft, but they never seem to land on the White House lawn. I mean, I don't know what that says. But the fact that we don't get deliberate, information from them, that they don't try and reveal themselves, as you say, and write something in the night sky that everybody could see, so there's no doubt. I have no idea. I mean, that's alien sociology. You have to ask the aliens. Who knows what their motives are? Maybe they regard us like I regard the ants in my backyard. I mean, I don't go out in the backyard and say, "Hey, ants, here I am." I mean, I just have other things to do in the day. But it might be worth pointing out Yet if
Okay, Seth, we have to take yet another short commercial break. But after the break, I want to talk about flying saucers and the recent disclosure that the military has been photographing these strange lights in the sky. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call at 612-564-8135. Leave your name, call letters to the radio station, and the city you're calling from, and then ask that question. Make that comment, and perhaps your thoughts will be heard on almost 100 radio stations that carry Science Fantastic. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Dr. Seth Shostack, author of the book, Confessions of an Alien Hunter. He has a PhD from Caltech, and he's the senior astronomer at the SETI Institute looking for alien civilizations in outer space. Go to their website, too, Big Picture Science, one word, bigpicturescience.org. Well, Seth, I got to ask you this. I'm broadcasting from New Mexico, not too far from Roswell, where some people think a flying saucer crashed back in 1947. However, I am speaking to other scientists and engineers. But, well, the United States military had to admit that, yes, the government does monitor these things. And, yes, they have picked up photographs of strange things up there that seem to buzz our aircraft faster than the speed of known aircraft. So what are your thoughts about these recent developments that the military and the government may know more than they're letting on? Well, what are your thoughts?
Well, it's true. 1/3 of the public does think that the aliens are buzzing our airspace, and an even higher percentage, this is kind of funny, but an even higher percentage think that the government is covering up knowledge of these things. Well, consider that. I mean, I've actually worked for the federal government, and I was never terribly impressed by their ability to keep secrets, but, who knows? But it does require that the aliens, whatever they're doing, they make sure that all the evidence of whatever they're doing is only available to the government and then can't be picked up by somebody who works at the local science museum in North Carolina or something. But even aside from that, even if you think that the government could keep something as interesting and important as visitation, could keep that quiet for the last 70 years, do you also think that the Bolivians and the Botswanans and the Belgians and the Brazilians and, everybody else is also keeping it quiet? Because if you don't, then you have to assume that the aliens only want to visit the United States. And, it could be because of our fast food. I have no idea. But, look, there's nothing that would be more interesting than to find out that our planet is being visited by beings from another world. And I to begin with, can't understand why anybody would think that would be kept quiet. But even so, I don't think you could keep it quiet, certainly not for 70 years.
Now, back in March, Vladimir Putin of Russia announced that they are perfecting a new kind of weapon, hypersonic drive, traveling not just at supersonic velocities, but hypersonic velocity, many, many, many times the velocity of sound. Some people think that maybe that's the source of all these UFO sightings, because the United States military then had to admit that, yes, they too have been experimenting with hypersonic drives. And just like the stealth bomber created all this wave of UFO sightings around Area 51, it was just a military craft, but the military had to keep it secret. Now the cat is out of the bag. The Chinese, the Russians, and the U.S., all three countries now admit they've been working on hypersonic drive. So what are your thoughts now when you see these photographs of something buzzing our aircraft, seen by radar, seen by multiple people? Is it just test drive of hypersonic weapons, or is it really some alien joyriding themselves in our atmosphere? What are your thoughts?
Well, I don't know everything the military is doing, obviously. So hypersonic drive sounds pretty interesting. I hope it doesn't make a big noise when they fire it up. But it's true that it's arguably true that many of the UFO sightings were in fact sightings of military aircraft or other vehicles that the general public just doesn't know about. That could be, but if you're really talking about craft that are alien, that are coming from some other star system, well, if that were really the case, if that was happening on a regular basis, then don't you think that some of the thousands of satellites we have in orbit around the Earth that are, looking down on the Earth, providing the images you see on Google Earth and other places, that they wouldn't have seen some of these? Or the hundreds of thousands of amateur astronomers who, on a clear night will go out and look at the sky, and each one of them is only looking at a tiny part of the sky, but you can, work out the numbers, and it turns out that collectively they're covering a lot of the sky, and they're doing it continually. And don't you think they might have seen something? I mean, it just doesn't seem to pass the smell test, as Carl Sagan would say. Yeah, I think that if it did, you would see exhibits at all those science museums. Hey, here's the evidence for visitation. And, I don't see it myself, but it would be nothing more interesting. It would be job security for me if we could prove that we're being visited.
And also, there's that famous TV series, Ancient Aliens, saying that maybe we've been visited in the past, looking at pictures that were carved by ancient civilizations that, sort of look like aliens. I've been on the show, you've been on the show, and I'm always careful to say that this is not proof. It could be nothing but artistic license. Somebody drawing a priest with lots of hair, feathers, and it looks like a helmet, it looks like an alien from outer space, but really it's ceremonial. But what are your thoughts? Have we been visited in the past?
Well, these things, ancient aliens, it usually considers artifacts that you find in South America, for example, the Nazca lines, which are, big drawings in the sand and so forth. They're not very old. They're maybe 500 years old. You can look at the pyramids in Egypt. They're a little bit older. That's 3,000 years old. But, none of this is very old compared to the history of the Earth. This is all essentially yesterday's stuff. But none of that is terribly convincing because you can think of alternative explanations for all of it. As you say, the Nazca lines, well, they look pretty neat. You see this, big turkey when you look at it from the air. But, why do you think that was made to contact aliens or maybe made by aliens? What about the pyramids? You say, oh, man, they must have had alien help to build those things. Well, no. I mean, these people weren't stupid, and they had lots of cheap manpower. So building the pyramids was a big, civil engineering project, but certainly not anything impossible.
Okay, Seth, unfortunately, we have run out of time, but if you want to find more about SETI Institute, go to the SETI Institute website or bigpicturescience.org, and you can listen to their radio program. Our special guest today was Dr. Seth Shostack, senior astronomer at the SETI Institute, the search for extraterrestrial intelligence. And Seth Shostack is the dean of scientists who are looking in the heavens for evidence that maybe there are advanced extraterrestrial civilizations in. Welcome back to Science Fantastic with Professor Michio Kaku. We profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, it's open mic. That's right, it's open mic on Science Fantastic. Here's your chance to talk back to the radio. Here's your chance to get on the air, to unload because you have a question or a comment about some of the big discoveries in science. The number to call if you want to get on national radio is 612-564-8135. And all we ask of you is that you leave your name, call letters of the radio station if you're listening to one, the city you're calling from, and bingo, you can ask that question. You can make that comment and have your thoughts heard on national radio. So let's say you're talking to the kids at dinner one day and your kids ask you a homework problem that leaves you stumped. What are you going to do? Look dumbfounded? No. You're going to get to the phones and call 612-564-8135 and tell your kids, ask that science question on air, and you can get on national radio. And no question is too dumb or too stupid to put on national radio. Sometimes the simplest questions are the questions that are so revealing about the nature of the universe itself. Also, if you want to find out more about what I do, go to my website, mkaku.org, mkaku.org. and you'll see the 4 New York Times bestsellers that I've written. The latest one is called The Future of Humanity. That is, the future of humanity in outer space. You know, the dinosaurs didn't have a space program, and that's why they're not here today. There are no dinosaurs in this room because they were wiped out when a comet or meteor slammed into Mexico 65 million years ago. And they were helpless. There was nothing they could do because they had no space program. Well, we do have a space program, and costs are dropping all the time, which will one day open up the heavens for human exploration. For example, maybe you saw the movie The Martian with Matt Damon. That Hollywood movie, a blockbuster, cost $100 million. But the Indian government put a probe on Mars. They sent a probe all the way to Mars for $70 million. So it costs more to make a Hollywood movie about going to Mars than actually going to Mars. And then in my book, The Future of the Mind, I talk about incredible research done using physics to probe the thinking brain. Did you know that by looking at blood flow in the brain, we can actually see thoughts as they emerge from the living brain? This is incredible. For example, old wives' tales can now be debunked or verified. For example, it's an old wives' tale that many people believe, but it's an old wives' tale that when a man talks to a pretty girl, he starts to act stupid. Well, it's absolutely true. By looking at brain scans of men talking to pretty women, you can actually see that blood drains from the prefrontal cortex behind their forehead, and they start to act mentally retarded. Absolutely true. And if you want to see that, just read the newspapers today, and you'll see this in action in the headlines. So that's the book, The Future of the Mind, talking about telepathy, telekinesis, all the things you see in science fiction movies that, yes, because of physics, we can now begin to probe the thinking brain and connect it to a computer. And then in my other book, The Physics of the Future, I talked about robots, jobs, medicine. What kinds of jobs are going to survive in the future? Where should you put your money when it comes to scientific investigation and research? And then in my book, Physics of the Impossible, I go 500 years into the future when things that seem impossible today become, well, who knows, commonplace. For example, starships. We hope to have starships perhaps within a century. Within 500 years, we may have something approaching what we see in the comic books. And then, not just that, but I talk about teleportation, just like what you see in Star Trek. Did you know that we can actually teleport atoms and photons today with today's technology? Anyway, these are the books profiled on my website, mkaku.org, mkaku.org. Or go to my Facebook site, Michio Kaku. There we have 3 million fans on Facebook. And on Twitter, we have about 650,000 fans. So find out what all the excitement is about. Just don't stand there staring at the radio. Get to the phones. Call 612-564-8135 and be part of the March of Science. Okay, let's move on now and take the first listener phone call.
Hello, my name is Jacob Hutchinson. My question for you is, I've read that if you fall into a black hole, you see the whole timeline of the universe flash before your eyes. Does that depend on the mass of you and the black hole, or is that a universal truth? Thank you.
Well, you ask a very interesting question because many people have wondered what happens when you actually fall into a black hole. What do you see? What sensations do you have as you fall into a black hole? Well, with our telescopes, we can actually see stars, star clusters falling into a black hole. The black hole basically has lunch. Now, realize that light, ancient light, can be trapped orbiting around the black hole. And so as you enter a black hole, you'll encounter ancient light that has been trapped, caught whipping around, orbiting around the black hole. So in some sense, when you fall into a black hole, you see the history of the black hole. When it was created, how it was formed. It's sort of like some people say when you have a near-death experience, you see your life displayed in front of you just as you are about to die. Well, in some sense, the same thing happens with a black hole, because a black hole has captured ancient light going all the way back to its original formation. And you see this when you go toward the black hole. Now, it's not very pleasant falling into a black hole. First of all, tidal forces, gravitational forces tugging on your toes, is different than the gravity forces tugging on your head, so you get stretched as a consequence, and that's called spaghettification. You literally become a noodle as you head toward a black hole, as tidal forces stretch your body until eventually your body disintegrates into atoms, and then the atoms themselves get ripped apart by gravity. Gravity rips apart the electrons from the protons, and so you are basically a bunch of gas molecules and subatomic particles as you enter the black hole. Now, if that isn't enough, time also slows down as you enter the black hole. Now, if you watch this suicide as you head toward a black hole, if you see this from a distance, so let's say you're in a rocket ship far, far away, watching this sad episode with a telescope, what do you see? Time slows down from your point of view. You see that it takes hundreds, thousands of years for that person to fall into a black hole, because the light from the black hole is what is called blue shifted. Frequencies change and time slows down. Now, if you are the unfortunate person to actually fall into the black hole, then it would only take a few seconds for you to fall into a black hole, depending upon where you started from. So from your point of view, you've already vanished into the black hole and perhaps are dead. But to someone far away watching this whole spectacle from a safe distance, you would see the person frozen in time, because time slows down as you head toward a black hole. In fact, I once read a science fiction story where the bad guy at the end of the novel falls into a black hole and he screams for 1,000 years. Well, I'm afraid that's it for the first segment of Science Fantastic.
Trading involves financial risk and is not suitable for all investors.
Marijuana has unleashed a green gold rush across our nation. It's creating $10.8 billion in new wealth a year. And every day, it's transforming more and more Americans into millionaires. Former Speaker of the House John Boehner reveals how you could become one of them. Join him online for the American Cannabis Summit. Attendance is 100% free, but space is limited. Join online at www.acs2018.com. John Boehner and an esteemed panel will reveal which cannabis stocks are primed to deliver life-changing windfalls. Plus, they will show you how to become a cannabis angel investor, backing the hottest startups before they potentially become worth billions of dollars.
To join the American Cannabis Summit, visit acs2018.com or text JOIN to 76280. Don't miss this once-in-a-lifetime opportunity. Text JOIN to 76280. Text JOIN to 76280 now.
This is Fred.
Hi, I'm Fred.
Fred's a repeater.
I tend to repeat.
Fred has a business.
I do have a business.
And a problem. Fred repeats the same tired advertising over and over, and now it doesn't work.
Over and over.
But Fred is about to see a vision.
I'm seeing a vision.
Advertising on the Genesis Communications Network is the smart way for Fred to reach his potential customers with the most affordable national advertising rates, period. Get started today with GCN, the Genesis Communications Network. Just email advertise@gcnlive.com.
Hi, I'm Dr. Bill Deagle, MD, AAEM, ACAM, A4M, of NutriMedical.com, and a consultant providing email advice free on advanced protocols for your optimized wellness and advanced technologies to heal and regenerate you. You can contact us at NutriMedical.com, that's NutriMedical.com, or 888-212-8871. You get free email starter protocols of our top medical-grade nutraceuticals, initial testing, and recommendations for your own primary doctor to do, as well as recommendations to give you an idea of a consultation and a full protocol to try to help you regenerate your tissues, heal naturally without the use of toxic polypharmacy. I can send test kits to you as well anywhere in the world and provide you recommendations to referral of specialty clinics worldwide. So contact me, Dr. Bill Deagle, at NutriMedical.com. That's NutriMedical.com or 888-212-8871.
The United States of Empire is a book that claims the United States is the empire of the world. George Washington had warned us against foreign wars. The United States of Empire shows that World Wars I and II left England broken. Its former colony, the U.S., had to save the empire. Was there ever a vote? Who do we fight for? The deep state began with World War I. The United States of Empire by James Dunn. Available at Amazon Books.
Thank you for listening to GCN. Be sure to visit GCNlive.com today.
Brought to you by Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. You're not going to get a busy signal 24/7, anytime, day or night. You can give us a call at 612-564-8135. All we ask is that you leave your name, call letter to the radio station if you're listening to one, the city you're calling from, and then ask that question. Make that comment that you've always wanted to make about science and the big headlines that you see practically every day in the newspaper. Okay, well, let's move on now and take the next listener phone call.
San Jose, California, Albert. 2001, A Space Odyssey, the movie, I'm sure you're well familiar with it. The computer, HAL 9000, do you think today they can make a machine just like HAL? And as far as consciousness that you've always mentioned about robotics and machinery, I don't think it would be self-aware. It merely mimics the human mind, but at a phenomenal rate of speed. That's why it outwitted the crew of Discovery 1. I've done a lot of research on that. So what's your opinion? Is there a HAL 9000 today? Certainly not from Urbana, Illinois. And I just wanted your opinion. By the way, he was a Capricorn, too, by the way, if that helped anyone out. Thank you, Dr. Michio.
Okay, well, first of all, yes, I've seen most of the great science fiction movies. I love going to the movies. When I was a kid, I would thrill at all the exploits of astronauts going into outer space. Today, however, I cringe a bit because being a professional physicist, I can see all the mistakes and errors that are made in the movie. However, you have to suspend your beliefs a little bit and just enjoy the show. I enjoy watching science fiction movies. And 2001, I think, is one of the most realistic movies, but I think they got the date wrong. Instead of being 2001, it should have been 2100. That is, I think he was off by about 100 years. 100 years from now, we may have regular manned journeys out to Jupiter and beyond. And perhaps by the end of this century, we'll have robots that are every bit as intelligent as us, and we can have intelligent conversations. Now, today we have Alexa and things like that are called chatbots. That is, they can talk to you, they can answer simple questions, but you can't engage them in gossip, you can't talk shop with them, you can't treat them as a friend. And that's where robots have failed. Robots are very good at things that are repetitive, things that don't require imagination or creativity, but they fail in 3 or 4 big areas. Listen carefully, because these are the areas where there are going to be jobs in the future. I repeat, the jobs of the future will be areas where robots cannot fill. One is human interactions. So, for example, in a law firm, the paralegal may be replaced because the paralegal is basically a search engine looking through law books. But the lawyer, him or herself, has to engage the jury, has to understand ethics and morals of society, which constantly change, have to argue to a judge and a jury. And so human interaction is one thing where robots are very deficient in. And this means that those jobs that require those skills will be around for quite a while. Next is pattern recognition. For example, our most advanced robots cannot fix your toilet. Things that are non-repetitive and require semi-skills cannot be done by robots. Robots cannot pick up garbage. They cannot solve a crime like what policemen can do. They cannot build a house like a carpenter. And they cannot make a garden like a gardener. But things that are repetitive, that's where robots can excel. So pattern recognition is another area that robots do not do very well at all. And then there's common sense. We know that water is wet, not dry. We know that mothers are older than their daughters. But how do you know that? How do you know that strings can pull and strings cannot push? Well, that's common sense. Any idiot knows that, right? Well, yeah, any idiot except robots. Robots do not know that water is wet because they never encountered water and wetness. I mean, why can't water be dry? And mothers are older than their daughters? Well, according to Einstein, that's not necessarily true. But for the most part, mothers are older than their daughters, but robots don't know that. And so jobs involving common sense will also be off the table for quite a while. And then jobs that require imagination, originality, innovation. Those are jobs that robots cannot perform well at all. So intellectual capital is going to be the currency of the future, not commodity capital like agriculture, making metals and different kinds of commodities, but intellectual capital, the capital of the mind, making jokes, creating new scientific theories, becoming a teacher and a mentor. These are things that require human skills, and that's where robots are lacking. And maybe in 2100, that movie, 2001, will in fact become very close to reality. Okay, let's move on to the next listener phone call.
Hello, Doctor. My name is John Cloud, and I'm calling from Pasco, Washington. The call letters of the radio station is KONA AM 610. I am wondering about a product that has been around surfacing here in the United States called Tribotex. It's they say smart nanoparticles. It goes inside of a gas and diesel engine. I want to know how safe that is and if that's a gimmick or what. Nanoparticles is a super lubricity. Could you please explain what that is? Thank you.
Well, there's a lot of hype around nanotechnology, which is the technology of individual atoms. And in the future, one day, perhaps we'll have atomic machines that are the size of atoms, atomic levers and gears and hammers. And that could create, of course, a new industrial revolution at the atomic scale. But where are we today with this technology? The promise is you could become a magician like Harry Potter. You wave your magic wand and a rabbit comes out of your hat because you rearranged atom for atom the molecules in that hat. We are far away from the promise of nanotechnology. So where are we with nanotechnology? One is lubricants. That is layers of surface with, let's say, carbon and carbon composites and graphene that can form layers on materials to give them strength, to make them slippery. And so that's one area where there is an industrial application, is in micro lubrication. Also, graphene, I mentioned. Graphene is a single layer of carbon. And as a consequence, scientists have been able to make transistors out of a single carbon atom, which will eventually give us molecular transistors. I mean, think about that. Instead of those clumsy silicon transistors that you find on your PC or your cell phone, we'll have transistors the size of carbon atoms, and that could give us a new industrial revolution. Now, there is some controversy, as you pointed out, and that is safety. At the present time, the safety tests on many of these chemicals have not been thoroughly done. And so we assume, for the most part, that these industrial lubricants are not going to be harmful. But hey, you never know. It's one of these things that still have to be tested. So for the chemical you mentioned, I'm not sure, I'm not familiar with that specific chemical, but you have to be careful because lubricants have been used, micro lubricants made out of nanotechnology, but you have to worry about how safe they are and whether or not, for example, the FDA has given any guidelines. But this is a frontier area. Another area where nanoparticles are very useful is medicine. It turns out that you can create nanoparticles that home in on individual cancer cells, killing them one by one. That is astounding. And some people think that's the future of cancer research, knocking out cancer cells one by one. One way to do that is to modify your immune system. This is called immunotherapy, so that it recognizes cancer cells and kills them. Another is to artificially create nanoparticles, which also zoom in on cancer cells and knock them out one by one. All this, of course, is still at the cutting edge, but one day nanomedicine can really turn ordinary medicine upside down. Okay, well, let's take another short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call at 612-564-8135. Science Fantastic with Professor Michio Kaku. In this hour, once again, we're going to throw the lines open because it's open mic on Science Fantastic. Here's your chance to get to the phones and give us a call. The hotline number is 612-564-8135. Let's say it's 4 o'clock in the morning, and all of a sudden you have this brainstorm. All of a sudden you just got to talk to somebody. It's such a great idea you have, but you're all alone. There's no one to talk to but me. That's right. You can call me on the phone by calling 612-564-8135 24/7. Anytime, day or night. You'll get a recording. Leave your name. Call letters to the radio station if you're listening to one, and the city you're calling from, and ask that question. Make that comment, and perhaps your thoughts will be heard on national radio. It's as simple as that. Let's move on now to the next listener phone call.
Hi, I'm Andrew Rosick, calling from Richmond, Michigan, and I had a question for you about light waves, and I was wondering if a wave of light was a dimensionless phenomena or had dimensions that can be explained. Thanks, Barrett.
Well, you ask a very intriguing question that has dogged science for centuries. Light does seem to be different from other objects. For example, if you take an object and you boost it, you have to, kick it or put a rocket on it, and it takes time. It takes time for an object to build up speed, and it's a question of inertia. So objects have inertia or resistance to change. Light, on the other hand, you turn on the light switch and bingo! It immediately races at the speed of light. No warming up, no getting up to speed. It immediately goes at the speed of light. And so you say to yourself, well, light really is different from other kinds of matter. It's really quite different. And the reason is the mass of the light beam is zero. Not that it doesn't have zero dimension, it has zero mass. Therefore, it takes no effort to simply turn on a flashlight and boom, it goes to the speed of light. No warming up, no revving of your engines, none of that. Immediately, it goes to the speed of light because the mass, the rest mass of light is zero. Now, some people say, now, wait a minute. Einstein said E equals mc squared. Energy is mass times c squared. M appears in that equation. So doesn't light have mass? And the answer is no. You see, E equals mc squared is actually a truncated equation. It's not the complete equation at all. The complete equation is quite different. And for light, it is energy is equal to momentum times the speed of light. And so momentum can even exist with zero mass. And so you see, the equations for light really are different from the equations for ordinary matter. But we know E equals mc squared. We don't know the equation for light because, unfortunately, they don't teach it in elementary school, even though they teach E equals mc squared. Now, does light have dimensions? And the answer is yes. In fact, it is a wave. You can graph it on a sheet of paper. In fact, it was James Clerk Maxwell 150 years ago who first discovered what light really is. If you get a magnetic field, for example, and you vibrate it, it creates an electric field. A vibrating electric field creates a magnetic field. That's how motors work. That's how your bicycle lamp works. Anytime something spins or moves, it creates an electric field and a magnetic field. Well, Maxwell then got a sheet of paper and drew this curve. You get a wave, one wave creating the next wave, creating the next wave. And then he asked the key question, a question which really changed human history. What happens if electricity turns into magnetism, turns into electricity, turns into magnetism, and it goes back and forth, and it creates a wave of electricity and magnetism. Well, let's take a short commercial break, and after the break, I'll answer the question, what is light? And how did Maxwell figure out what light is?
Would you like to get back that full head of hair from years past? Now, there is Reveal. Beverly Hills celebrity dermatologist Dr. Nathan Newman took nearly a decade to develop Reveal from natural botanicals to return to a full-body head of hair. Reveal for men and women with a 30-day money-back guarantee at gcnlife.com or toll-free 844-443-6637. 844-443-6637. Reveal at gcnlife.com.
It's been said, any society is only 3 missed meals away from chaos. Those times may be near. Think about it. Our country faces multiple terrorist threats and aggressions from Russia and North Korea. Social unrest and violent marches yet again may lead to looting of stores and city shutdowns. And our crumbling infrastructure leaves our power grid vulnerable to long-term outages from a single cyber attack. When the chaos from any one of these threats arises, the government knows it can't provide during a widespread national emergency. That's why you need your own plan for self-reliance. That's where My Patriot Supply comes in. Get a 4-week survival food supply for only $99. That includes breakfast, lunches, and dinners. Order online at preparewithgcn.com. $99 for 4 weeks of survival food that tastes like homemade cooking and lasts up to 25 years. From My Patriot Supply. Get your kits today at preparewithgcn.com. Free shipping is included. Preparewithgcn.com.
Most of you know that heart disease is the #1 silent killer in the U.S. What if I told you for just $54.95 a month you could fight against heart disease naturally? At Heart and Body Extract, we've been helping thousands of people get back to a healthier heart. Don't just take my word for it. Check out all of the success stories at hbextract.com. Or to order, call 866-295-5305. That's 866-295-5305. hbextract.com. Don't risk it when you can take charge of it.
Advertising is simple. It starts with someone who has a need.
Mom!
And then gets more specific.
Mom, I want pizza.
Then we add urgency.
I want pizza tonight.
Before you know it, your GCN advertising message is reaching millions of listeners. Listeners who are definitely in need.
We want pizza!
You see, advertising on GCN is simple. Your message meets their need, and the result means new business for you. Tell us about your business. Then let our super creative department go to work to craft just the right message to feed those who have an urgent need.
We want pizza tonight!
GCN has the most affordable national radio advertising rates, period. And millions of people listen to GCN radio programs on over 1,000 AM and FM and XM stations and streaming audio live. Get started today with GCN, the Genesis Communications Network. Just shoot us an email, advertise@gcnlive.com.
Brought to you by Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 612-564-8135. And before the break, we had a question about the nature of light. And then the question is, what is light anyway? It seems to be so different from ordinary matter. Well, that was actually figured out 150 years ago by the British physicist James Clerk Maxwell. We know about electric fields. For example, electric fields make your hair stand on end if you get charged up. It's the spark you feel by walking across the carpet. It's the electricity you get from the wall. And it's the electricity you get in a lightning bolt. All these are due to electric fields. Then we have magnetic fields, like the magnetic field of the Earth, which makes compass needles point in the direction of north. And then you have dynamos and motors. How do they work? Electric fields turn into magnetic fields, which turn into electric fields. So, Maxwell said, if I have an electric field and it turns into a magnetic field, and like a ping pong, it goes back and forth, it creates a wave. And then he said to himself, well, that's nice. If vibrating electric and magnetic fields create waves, then what is the velocity of this wave? Well, it's a very simple calculation. He calculated the speed of the wave, and then he practically fell off the floor. He made one of the greatest discoveries in the history of the human race. He discovered that the velocity of a wave created by electricity turning into magnetism, turning into electricity, the velocity of that wave is the speed of light. And then he said, I paraphrase, he said the most momentous words of the electric age. He said, this is light. Light is an electromagnetic field. It's a field created by electricity turning into magnetism, turning into electricity, vibrating back and forth like a ping pong ball, traveling at a velocity, and that velocity is the speed of light. And then Maxwell said, this is light. One of the greatest discoveries in the history of the human race. And then Einstein, a century later, actually about 40 years later, took these equations of Maxwell and finished it. Unfortunately, Maxwell died when he was 40-something years old, and he was not able to complete his theory. Einstein took Maxwell's theory and said, this is just the beginning. That is, if this is light, then let's calculate the speed of light as you go in any direction. And then Einstein realized that the light beam traveled at the speed of light no matter how you looked at it. And then he came up with the theory of relativity. And so what is light? Light is an electromagnetic field. Electric fields turning into magnetic fields, turning into electric fields, traveling at a velocity, the velocity of light itself. Okay, let's move on now to the next listener phone call.
Hi, my name is Shane Thompson. I'm listening to iHeartRadio, KFBX, Fairbanks, Alaska. I'm currently in Fountain Valley, California. My question for Michio Kaku is, what are your thoughts on the grand solar minimum? The way the sun seems to have an effect on our weather here on Earth and causing climate change. Thank you.
Okay, yes, if you take a look at the sun and graph the sun's output over a long period of time, you realize that it's not steady. You begin to realize that there are fluctuations in the sun. And for example, years ago, the sun's intensity was different than it is today. And if you look at the history of stars in the heavens, there are so many stars in the heavens that you can see stars in any phase of their life, from birth to maturation to eventually they die or they undergo supernova. You can see stars at any phase of their existence. And so with stars, we can then compare the life history of thousands of stars to the life history of the planet Earth. And you see that, yes, it turns out there are cycles, that there are areas where light can diminish or expand. However, I'm not so much worried about that. I'm worried about when the sun has a temper tantrum, that it erupts with the fury of a solar flare. Let's take a short commercial break, and after that break, I'll talk about what happens when all hell breaks loose, when the sun unleashes a temper tantrum and creates what is called the Carrington event, which can really ruin your day. So give us a call at 612-564-8135, and maybe you can get on Science Fantastic. To Science Fantastic with Professor Michio Kaku. Once again, if you want to be part of the March of Science, then give us a call at 612-564-8135. And remember, no question is too dumb, too stupid, or too dumb to put on national radio, because sometimes the dumbest questions are the most profound of all. They're the most revealing of the secrets of Mother Nature. And so give us a call at 612-564-8135. Before the break, we had a question about the sun. Yes, the sun does have cycles. Yes, the sun's intensity can increase or decrease. But does that cause global warming? No, it is not sufficient to influence the weather that much, especially because the weather has been changing over the last 100 years. And many of these cycles take place over a period of thousands of years. However, there's one kind of event that really, really does worry climatologists, and that is a gigantic solar flare like the Carrington event of 1859. It was a gigantic explosion on the sun as a solar flare went hurtling from the sun and hit the earth, and it was seen by the astronomer Carrington. That's why it's called the Carrington event, and it influenced telegraph wires back in 1859. Now, we physicists today, knowing the intensity of what it takes to disturb telegraph wires, can then now extrapolate to what it would be like today if a Carrington event were to erupt today. And it's not going to be very pretty. Property damage will be on the order of $2 trillion. That's trillion with a T, not a B. It means that power plants would be short-circuited, satellites would be fried, telecommunications will be disrupted, the internet will go down, your power in your house would go out as the power supply is short-circuited. Credit cards cannot be taken because, of course, everything's offline. And it means that refrigerators are all going to go on the blink because there's no power, which means food riots. Food riots in the next few days. It's going to be a real mess. And so we physicists, knowing this, went to Congress and said we need a few $1 million in order to reinforce our satellites, reinforce our power plants, build redundant systems as a safety precaution. And all we get was Snickers from Congress. So much for alerting our wise lawmakers about a real potential catastrophe when the sun erupts in the fury of a gigantic coronal mass discharge like what we had before. Now, how often are they? We don't know. Perhaps on a scale of hundreds of years, we don't know. We've only had one, and working backwards, we've been able to work out the dynamics of that solar flare and exactly how intense was the electric field. For example, we know that as you travel north, you get the aurora borealis because of the solar wind which hits the North Pole. However, during the Carrington event of 1859, as far away as Cuba, they saw the Northern Lights. The Northern Lights not in Finland or Sweden. No, the Northern Lights in Cuba. That's how massive this solar flare was. And as I mentioned, we physicists can then reverse engineer that to calculate the intensity of that solar flare. And it was humongous. It was off scale, meaning that every few hundred years, a whopper is going to happen. And remember back in 1859, what did we have? Did we have television? Did we have the internet, iPods, iPads? No. We had Morse code, and telegraph wires. That's all we had back in 1859. Think of what that would do today to our power plants, to the satellites, the internet, telecommunications, telephones. It would be a real mess. Okay, let's move on now to the next listener phone call.
Hi, Dr. Kaku. My name is Eddie. I live in Ogden, Utah. I just watch your show or listen to it on YouTube, rather. I had a couple questions that maybe you could clarify. I think that your listeners would really be interested in is, can you explain what frame dragging is, as well as the tachyon anti-telephone paradox? Thank you. Love your show.
Okay, frame dragging is a consequence of Einstein's theory of general relativity, where space and time have a life of their own. They are a fabric which can bend and stretch, and that gives us the appearance of gravity. So the pulling and tugging of gravity is actually the pulling and tugging and stretching of space. Now, as a black hole rotates, it's like molasses rotating. And if you are, let's say, a bug floating in molasses, you are dragged along with the molasses as it spins. That's called frame dragging. So frame dragging is when you have, for example, a black hole, and you're caught up in the wake of the spin, and you are then dragged along with the frame being space and time. So that's how that works. And we actually see frame dragging. This was, of course, a consequence of Einstein's theory of 1915, but we actually see evidence of this as we see entire star systems and gas clouds sucked right into black holes as they have their lunch. And then tachyons. Well, first of all, let me explain what a tachyon is. A tachyon is a hypothetical particle that goes faster than the speed of light. And if it goes faster than the speed of light, then in some sense, it gives you a form of time travel. That's why we physicists are very skeptical about the existence of tachyons. Of course, on Star Trek, tachyons are a preferred way of communicating because it would allow you to communicate faster than the speed of light. However, don't believe it. We have seen no evidence of tachyons. Maybe a tachyon destabilized the Big Bang at the beginning of time, but that's about it. So far, we see no evidence of tachyons. Well, unfortunately, that's it for Science Fantastic. Once again, join us every week as we explore the cutting edge of science on Science Fantastic. And give us a call. The hotline number is 612-564-8135. Leave your name, call letters of the radio station, and the city you're calling from, and then ask that question. Make that comment, and maybe you can get on national radio. Good day. Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And give us a call if you want to get on Science Fantastic. The number to call is 612-564-8135. All we ask is that you leave your name, call letters of the radio station if you're listening to one, and the city you're calling from, and then ask that question. Make that comment, and perhaps you could get on Science Fantastic with Professor Michio Kaku. Now, sometimes people email me and say, well, I'm too bashful to have my name heard on national radio, but you can send me an email. Go to the web and go to my website, mkaku.org, mkaku.org, and you can ask that question, and then perhaps I'll read your response on national radio. And go to my website, mkaku.org, mkaku.org is the website. If you go to my Facebook site at Michio Kaku, we have 3 million fans on Facebook, over 600,000 fans on Twitter. So find out what all the excitement is about. And let's say it's 4 o'clock in the morning, and you're all alone, and something just pops into your mind, something about health, something about the future, something about evolution, something about DNA, something about the universe, but there's no one to talk to. Well, you can talk to me. You can give me a call. 612-564-8135 is the number to call, and then you can ask that question, make that comment, and perhaps you can get on national radio. And also, I've written 4 New York Times bestsellers. My latest one is called The Future of Humanity, about the future of the space program. We're talking about going back to the moon. Starting next year, an unmanned probe will be sent back to the moon. Then 3 years after that, we're going back to the moon with astronauts. Then on to Mars and beyond, perhaps to the asteroid belt, and maybe one day to the stars. Find out about what all the excitement is about by getting a copy of my latest book, The Future of Humanity, talking about the future of the space program. Okay, well, let's get right to the listener phone calls. So let's have the first call.
Hi, this is Tom Myers from Rochester, New York. I saw this on a tweet. What will it take to get the U.S. to use the metric system, period? Our students are being forced to learn 2 systems. Their main system, it gives them a handicap when they're using science. This is not a good thing. Thank you.
Yes, I sympathize with you wholeheartedly. When I go traveling around the world, I realize that everybody uses the metric system. Everybody talks in terms of meters and centimeters, except when they come back to the United States. It's back to the old U.S. system. Now, at one point, there was a national campaign years ago to convert to the metric system. However, it never materialized because of, force of habit. It costs money to make the change. And it also is a question of inertia, bureaucratic inertia. You see, politicians don't get points. They don't get reelected by being the champion of the metric system, and people are naturally conservative. Now, in other countries, they have to convert because if you want to engage in commerce, international commerce, then you have to go to the metric system. However, the United States is the 800-pound gorilla. As a consequence, we wanted them to conform to us. Let them convert metric system and our system. Now, it turns out this has practical implications. Years ago, we sent a Mars probe into outer space, and there was a miscalibration because of the conversion from the English system to the metric system, and our space probe was lost as a consequence. So in other words, this has million-dollar consequences. It's not just a question of inconvenience. It's also a question of mistakes are made as a consequence. But politicians have to get behind it, and unfortunately, there's no brownie points that politicians get by pushing something that's unpopular in this country like the metric system. I sympathize with you, but ultimately, it's up to the politicians. Sorry about that. Okay, let's move on to the next listener phone call.
Stephen Winter calling from Clinton, Mississippi. Radio station's 103.9 WYAB. My question is concerning global warming. If I'm not mistaken, when I was in high school in the 70s, they were talking about us coming out of a mini ice age or something like that. They were expecting it to get warmer back then. I just wondered what's happened between then and now. Was that information off track, or we got folks wanting to blame everything on CO2 emissions, which I believe one volcano produces a huge amount. Anyway, that's my question. Just curious about that. Thank you.
Okay, well, you ask a question that's very relevant for today. First of all, there are 2 kinds of atmospheric disturbances. One is long-term and one is short-term. Now, ice ages come and go on a scale of tens of thousands of years. The last ice age ended 10,000 years ago, and that made possible the rise of civilization. Civilizations could not exist when most of North America was covered with a half a mile of ice. And so we were basically nomads going from one small hunting site to another, chasing after the deer and the buffalo, who also migrated. And it was a very hard life. Then 10,000 years ago, the ice melted, making possible civilization. But these are long-term cycles. In another 10,000 years, we will have another ice age. In other words, 10,000 years from now, don't be surprised if America is under a half a mile of ice. Now, the other question is about global warming. Now we're talking about things that change the weather, not on a scale of tens of thousands of years, forecasting another ice age in 10,000 years, but cycles which happen on a scale of decades to centuries, which are usually not natural. Natural cycles usually take thousands to hundreds of thousands of years. But here we're talking about a change that's taking place on a scale of decades. When you look at the last 100 years, for example, you realize that since the Industrial Revolution, temperatures have risen about a degree, that also sea levels have risen at a very measurable rate, caused by the warming of the oceans. Now, the Earth is warming up. You can talk to any farmer. Any farmer will tell you that his or her livelihood depends on knowing when to plant and what the seasons are. And yes, summertime is about a week longer than before. So global warming, just in the sense of warming, is here. Even President George W. Bush years ago said, quote, something is happening, unquote, with the weather that even the average person knows. Now, here's where the debate comes in. The debate comes in as to how much human activity is responsible for global warming. So in other words, even the so-called skeptics will concede now the fact that the Earth is warming up. We can see this with satellite data, oceanic data, but then the question is, who's responsible? Well, we'll talk about that after the break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call. The hotline number is 612-564-8135. Call that number and ask that question that you've always wanted to call. Science Fantastic with Professor Michio Kaku. Once again, if you want to get on the air and ask that question, give us a call at 612-564-8135. You'll hear the beep. Leave your name, call letters of the radio station, and the city you're calling from, and then ask that question. Make that comment, and perhaps your thoughts will be heard on national radio. Well, before the break, we had a question about global warming. Yes, even the skeptics will say that the Earth is warming. And years ago, I was a skeptic myself. I used to say to myself, come on, now, give me a break. The Earth is so big. It's huge. And humans, we're so tiny. How can we humans influence something as big as the weather? But then you take a look at what's happening with the Earth itself. All the indicators show that the Earth is warming and it's accelerating. We see that all the major glaciers are receding. All the major glaciers are receding on the planet Earth. Parts of Antarctica are beginning to break off. The stability of Antarctica is now being questioned. We see the fact that summer times are about a week longer than normal. And we see that global swings of the weather are commonplace now. 100-year floods, 100-year forest fires, 100-year this, 100-year that. They seem to be happening all the time. And then the big question is, how much of it is due to human activity? Well, scientists use computer programs. Some people don't like them, but what else are you going to do? Use pencil and paper? When you use computer programs to run the videotape, what you find is that with 90% confidence, it is human activity. Now, 90% confidence is not 100%. Scientists are not saying that with 100% accuracy we say that it's human activity, but with 90% confidence they say it's human activity that is causing the Earth to heat up. Okay, well, let's move on now to the next listener phone call.
Hi, Dr. Kaku. This is Ben in Chicago. Are atomic events recorded in space-time similar to the way in which digital data is recorded on storage media? And if so, would it be theoretically possible to read historical events of the past and then recreate them in the present? In other words, you'd be time traveling to the past, not to alter the past, but to gather data of past events and then recreate them in the present, so you could perhaps alter past events in the present. Doing this would avoid any time-traveling paradoxes, and it could be a way to resurrect a dead person by recreating their bodies and memories in the present time in a way that wasn't possible in the past. Thanks.
Well, you actually ask a question that I used to ask myself as a youth a long time ago. Let's say there's a crime. The light emitted from the crime has bounced off the walls, but if you could reassemble all the light, then you could, in principle, recreate the scene of the crime. So I thought to myself, wow, I mean, we have all this knowledge about atomic physics. We have all this knowledge about atoms and photons and electrons. Why can't we collect all this data, not digital data, but atomic data, and then run the videotape backwards to reconstruct the crime? Well, great idea, but in practice, it's not practical for several reasons. First of all, when light scatters off a substance, let's say there is a crime and light from the crime hits the walls, light scatters in all these different directions. And to recreate that wavefront would require you to know everything there is about the original wave, everything about the texture of the wall that bounced the light off, and the amount of data would be incredible. And so it's not possible using ordinary techniques to then recreate the wavefront. Sorry about that. However, some people have suggested that even though we can't duplicate the atomic data, the digital data may somehow be reconstructed to create an approximation of reality. This is called digital immortality. One Silicon Valley company is already offering to digitize everything known about you. Your credit card records, your Instagram pictures, everything known about you on the web can be digitized to get you a first approximation to who you are. Now, as time goes by, more and more information will be collected about you, to the point that we may be able to reconstruct a reasonable facsimile of who you are. And the Silicon Valley company actually is offering to create a robot that looks like you, talks like you, has the same mannerisms as you. I've actually seen the robot, and it's not very advanced, so don't get your hopes up. But the question of digital immortality is a possibility. For example, take a look at Winston Churchill. Let's say you digitize everything known about Winston Churchill. So when you go to the library, you talk to him. You talk to a holographic image that reproduces the sound, inflection, historical notes, everything known about Winston Churchill. I mean, I wouldn't mind talking to Einstein. I'd have a great time talking to Einstein, or even a reasonable facsimile of Einstein. And then, maybe decades from now, the Connectome project will be finished. The Connectome project will map the entire brain. Every neuron of the brain can be mapped to recreate a facsimile of your thinking brain, including your memories, your personality. We're talking about a digital version of you that is immortal. Now, is it really immortal? Well, to paraphrase former President Bill Clinton, it all depends on how you define you. If you are a biological being, then no, this is nothing but a digital tape recorder. However, if you is the sum total of all the information that is known about you, your mannerisms, your feelings, your memories, everything known about you, if that is you, then in some sense we have digitized your soul. So your soul is now being reduced to information. Now, is this possible? Certainly possible. Is it economical and practical? That I don't know. But as computer prices continue to drop, some people may want the option of not biological immortality, but digital immortality. Okay, let's move on to the next listener phone call.
Barton Salen, listening on WSRQ in Sarasota, Florida. Since general relativity says that a clock on the sun would run slower than a clock on the Earth because of the greater gravitational force on the sun, if a clock could survive on the sun, doesn't that mean that those time differences between the sun's clock and our clock would accumulate so that when we look at the sun today, we would not be seeing it as it is today, but rather as it was in the time of the dinosaurs? Now, I realize that today we see the sun as it is today because when there is a flare on the sun, if it's in the right position, we get hit a few hours later by particles from that flare. So we know that we're watching the sun as it is today. Thank you.
Yes, well, you ask a very interesting question. It turns out that the speed of gravity is the speed of light. If the sun were to disappear right now, it would take 8 minutes. 8 minutes for that information to hit the Earth. So even gravity has a finite speed. Now, as you pointed out, time beats at different rates throughout the universe. On the moon, time beats faster. So if I have a clock on the moon and a clock on the Earth, and the two clocks can talk to each other, the clock on the moon beats faster than a clock on the planet Earth. And this is actually measurable. So this is not science fiction. This is science fact. Get used to it. In fact, Einstein once said that he put a clock at every point in the entire universe. He put a clock, all of them beating at a different rate, but he was so poor he couldn't afford a clock of his own. But it's true. Time beats at different rates throughout the universe. So you're saying, can you accumulate this difference in time? The answer is yes, but it is infinitesimal. So if I have an astronaut on the moon and an astronaut on the Earth, a twin, and they eventually meet years later, they will only be a fraction of a second delayed between the two twins. It's a very tiny effect. So don't think that it has any practical applications at all. But you're right, time beats at different rates. Okay, let's take another short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Give us a call at 612-564-8135.
Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. That's right. It is open mic on Science Fantastic. Here's your chance to ask that question that you've always wanted to ask but never had the opportunity. You can give us a call at 612-564-8135. Leave your name, call letter to the radio station you're listening to and the city you're calling from, and then ask that question. Make that comment that you've always wanted to do. And remember, no question is too dumb to put on national radio. Sometimes the dumbest questions are the deepest and most profound questions of all. And also, go to my website, mkaku.org is the website to go to, mkaku.org. And find out about my 4 New York Times bestsellers about the future of science, the future of jobs, the future of economy, the future of space travel, all of it contained in my books. Okay, let's move on now to the next listener phone call.
Hey, this is Armand from Queens, New York. I listen to you on YouTube. I was wondering, why do you think Elon Musk thinks that we live in like a simulation like, we're a simulation pretty much. We're, made by computers or whatever. I know you believe in the multiverse theory. Well, why do you think Elon Musk believes that we're like a simulation or like a program? Thank you. I love your show. Have a great one.
Excellent question. Well, as I mentioned in my book, The Future of Humanity, we have Silicon Valley billionaires affecting the direction of the space program. And so these people made their money on the internet. For example, Elon Musk was a PhD candidate in physics, like Wernher von Braun, the famous rocket scientist. Elon Musk also went into the PhD program in physics, but after just 2 weeks at Stanford University, he decided, nope, this is not for me. The money is in Silicon Valley. So people in Silicon Valley think that you can digitize everything. But you see, there are limits to what you can digitize. For example, how many atoms are there in your body? I mean, there are 10 to the 23 atoms in a mole. Your body consists of many, many moles. And so the number of atoms in your body could be on the order of 10 to the 26 atoms. That's an enormous number of atoms that you cannot digitize. Take a look at the weather. The smallest object that can simulate the weather is not a supercomputer. Even a supercomputer cannot model the weather and every atom of the weather accurately. The smallest object that can model and reproduce the weather is the weather itself. So we say that these things are not calculable. There are simply so many ways in which atoms can vibrate inside a gas to create the weather that is simply not practical to build a machine that can duplicate every single atom bouncing around inside the atmosphere. Now, people and reality is much more complicated than the weather. And so that's why even classical physics, Newtonian physics, cannot be modeled using a computer. It cannot be digitized. Now, quantum mechanics makes it worse. Quantum mechanics says that all possible universes are possible. And so you would have to digitize not just one universe, you would have to digitize all possible universes in the world of quantum mechanics. And that's why I say that the movie The Matrix was great, but it's a movie. Get over it. It's a movie. We are not living in a simulation. Okay, let's take a short commercial break. Once again, you are listening to Science Fantastic. Give us a call at 612-564-8135 and ask that question that you've always wanted to ask. The lines are open. You're not going to get a busy signal. Give us a call at 612-564-8135. When you hear the beep, leave your name, call letters of the radio station, and the city you're calling from, and then make that question. Make that comment about science, and perhaps your thoughts will be heard on national radio. Okay, let's move on now to the next listener phone call.
Hello, sir. My name is Dale Phillips. I'm actually not listening to a radio station. I'm looking you up online, and I'm calling from Bahrain, in the Middle East. My question is sort of have a two-part question. How close are we to making colonies on other planets or even the moon? Or making colonies elsewhere other than Earth is what I'm trying to say. Exactly how close we are to doing that. And also, one of my favorite episodes of yours is the episode of Sci-Fi Science where you make the lightsaber. How close are we to making the lightsaber from the time you made that episode to now? So I apologize for the two-part question, but that is my two most favorite interests. So thank you very much. My name is Dale Phillips from Bahrain, and hope to hear from you soon. Thank you.
Well, what a phone call. Yes, I've been to the Middle East, and yes, I'll try to answer your questions. First of all, the colonization of planets is still going to be decades away. Just last December, President Donald Trump issued the Space Policy Directive number 1. And that Space Policy Directive reversed the policies of Barack Obama. Barack Obama basically ended the U.S. manned space program. He canceled the space shuttle, canceled the replacement for the space shuttle, canceled the moon program, and then also canceled the Mars program. However, Space Directive number 1 says we are going back to the moon, then to Mars, and then beyond, perhaps the asteroid belt. Now, let's be real about this. The timetable, of course, is still speculative. Starting December of 2019, the end of next year, NASA intends to send the SLS booster rocket into outer space, and the capsule will go around the moon, unmanned capsule. Then, around 3 years after that, astronauts will go back to the moon. And then around 2030 to 2035, that's when the first astronauts will go to Mars. And then once we're on Mars, we have to set up a Mars colony. And that'll, of course, take even more time. Perhaps we'll use a lava tube as a makeshift base of operations to protect us against cosmic rays and the harsh atmospheric conditions of Mars. Then we'll create a power plant by putting out solar panels and then begin mining operations. Why that? Because ice is a valuable commodity. Mars has plenty of ice. It's a frozen desert. Ice can be melted and purified to give drinking water, broken apart into oxygen and hydrogen to create rocket fuel for the return mission. So again, first we go to Mars, put our flag on Mars, set up a impromptu base of operations, but then we're talking about long-term operations, basically starting mining to extract water. After that, we're going to set up a agribusiness. In other words, we're going to use genetic engineering to create varieties of algae and crops that can be sustained in the harsh conditions of Mars. The goal is to make it self-sustaining, so it's not going to cost anything at all. For example, it turns out that Mars rock can be melted using microwave radiation. This has actually been done in the laboratory to create duplicate rock of Mars, hit it with ultraviolet radiation, and melt it to create brick. So in other words, it's possible to use the soil of Mars to create brick, which will be used as building materials. It'll be possible to mine the ice to create the first mining operations, and then melting the ice caps using solar satellites to beam the energy down to the poles. Now, we're talking decades. We're not talking anytime soon. But you got to start somewhere. And maybe mining the asteroids could help pay the bill, because the asteroids have plenty of platinum chemicals. Well, unfortunately, that's it for Science Fantastic. Once again, if you want to get on Science Fantastic, give us a call at 612-564-8135 and ask that question. Make that comment that you've always wanted to do on national radio. So this is Science Fantastic with Professor Michio Kaku. Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing developments in science and technology that touches your lives and changes the destiny of nations. And again, if you want to get on Science Fantastic, give us a call. The hotline number is 612-564-8135. And again, leave your name, call later to the radio station and the city you're calling from, and then ask that question. Make that comment that's always been bothering you about science. And once again, no question is too dumb to put on national radio. Years ago, a 16-year-old boy asked a really dumb question. Can you outrace a light beam? It took him 10 years to answer that question, from the age of 16 to the age of 26. But when he was 26 years old, he finally answered that question. Can you outrace the light beam? Well, that 16-year-old boy was called Albert Einstein, and his theory changed the destiny of humanity. He understood what makes the stars shine, the energy behind atomic and hydrogen bombs, the technology that we see in our living rooms in the form of the internet, transistors. A lot of this technology goes right back to Albert Einstein, who asked himself a simple question: can you outrace the light beam? So you can also be part of the March of Science by giving us a call at 612-564-8135 and ask that question. Make that comment. Well, before the break, we had a two-part question, and that is, what would it take for us to build a colony on other planets? And, well, in the 2030s, that's the earliest we could have humans on the red planet. And then it'll take decades after that before we set up the first mining operations, we set up the first agribusiness, and we make it self-sustaining for colonists. And then to create a paradise on Mars, we would have to send solar satellites to then beam solar energy down to the polar ice caps to melt the polar ice caps so that liquid water flows on the surface of Mars once again. And so hopefully, perhaps late in this century, we will have a self-sustaining Martian colony that's not going to cost anything, so that colonists will have a self-sustaining economy based on mining operations, based on agribusiness, to create a permanent settlement on Mars. And then beyond that, well, get a copy of my book, The Future of Humanity, where I talk about going beyond that to Europa, to Titan, and then perhaps even to the nearby planets surrounding other star systems. Now, the other part to the question that we had earlier was the lightsaber. Well, for the Science Channel, I once hosted a science series where we went through the hardware of science fiction, looking at them from the point of view of a physicist. So we looked at the lightsaber. Now, first of all, the lightsaber has a problem, and that is it extends a finite distance from the hilt. Now, how do you do that? Light, of course, simply keeps on going forever unless it bounces off something. So one way in which you can create the temperatures of a lightsaber is with a plasma torch. Plasma torches are actually commercially available. It's basically a large spark that can create a plasma. Now, a plasma is the fourth state of matter. We have solid, liquid, gases, but the sun is not made of a solid, liquid, or gas. The sun is made out of a plasma. That is a gas of dissociated atoms that have been broken up, and you can create plasma using electricity. So if I have a plasma torch, then I could use that to cut right through steel, for example, and simulate a lightsaber. However, it's not a true lightsaber in the sense that it goes a finite distance. A lightsaber, of course, is based on light, which can in fact go an infinite distance. But this is as close as you can get to a lightsaber using today's technology. So the lightsaber would have to have a spine. It would have to have a spine that then emits the plasma from the spine and then creates the lightsaber. Now, it is not exactly what you find in Star Wars, but it's as close as you can get using today's and tomorrow's technology. Okay, let's move on to the next listener phone call.
Yes, Dr. Kaku, this is Justin from Texas. I listen to KMET. I was just wondering, what do you think the current administration of the United States is going to do about the problems we have with the space station, International Space Station? What do you think? They're talking about, I guess, renting it out. What do you think the best idea would be to use with the International Space Station? Thank you very much.
Well, you ask a very embarrassing question because at the present time, we don't know what to do with the International Space Station. First of all, let me explain what the administration is doing. The The Trump administration has issued, at the present time, 3 space directives. Space Policy Directive 1 talked about going back to the moon, then to Mars and beyond. The second directive talked about private enterprise and encouraging the deregulation of outer space. The Space Directive number 3 talked about space junk. So the administration has not yet stated what its policy is toward the space station. Now, it depends on who you talk to. If you talk to a pure scientist, they would say that we get actually very little new science from the space station. So they say that we perhaps don't even need a space station. Other people say, what a waste, $100 billion, and we're just going to let it deorbit and burn up like a meteor. At the present time, the only practical application would be to commercialize it. But we'll see. But unfortunately, we have run out of time in Science Fantastic. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Join us every week when we discuss the cutting edge of science. And go to my website, mkaku.org, mkaku.org, and find out what all the excitement is about. Once again, this is Dr. Michio Kaku for Science Fantastic.